Hey everybody, this is me from out of the state. I'm in Hawaii right now, hate to admit it. Doing a family thing, and we're going to go ahead and jump in and look at the 10.1 homework questions. So let's go ahead and fire this up. I was looking at these problems and I felt like number 3 was a little more advanced than 1 or 2. So I'm going to go, it's the same math, but the setup on the null hypothesis is a little different. So I think we'll just jump in and look at this one. So it says a gift shop sells men's t-shirts and the manufacturer advises about 10% of the shirts are sold small, 30% are medium, 40% are large, and 20% are extra large. After selling 220 shirts, the gift shop summarized the sales as the frequencies recorded below, so each of these. But for this hypothesis, let's go ahead and read this. It says, test the claim that the proportions for each of the 4 shirt sizes are as given up here by the manufacturer against the alternative that they're not all correct. So we're going to use a 1% level of significance here. So the first proportion, this is for the small shirts, which are 10%, we'll do 0.10. For the medium shirts, it says 30%, 0.30. For the large, it should have been 40%, 0.40. And the extra large would be 20%. These should add up to 100%, so I'm going to double check. 60, 90, 100%. Good. Okay, so we're all good there. And then we have to do the observed frequencies and the expected frequencies. So the observed frequencies are just the quantities that were sold, but the expected frequencies would be based on these proportions. So just as a reminder, expected frequency is always n times p for these binomial or multinomial experiments. So for the small shirts here, we expected 10% of 220. So if you do n times p, that'll be 220 times 0.10. And we do this over here. So 10% of the 220 should have been small. So that's 22 shirts. I'll go ahead and key that in down here. That's the expected frequency. Okay, then for the medium shirts, it says 30% should be medium. And that's what we have down here. 30% is the second proportion. And again, we're just doing n times p to get the expected frequencies. So n was 220, so we'll go ahead and do that. 220, that's n times p. The proportion should have been 30%, so 0.30. Okay, so that's 66 shirts for the expected frequency. Oops. Now for the large shirts, the claim is, again, 40% should be large. That's what we have, the third proportion, our third p value. E is n times p, so we'll do n, which is 220, times 40%. Okay, and so here we get 88 is expected here. Pretty close. If you look at these frequencies, the small shirts are pretty off, 12% to 22. Seems like a big mistake, but the rest of these are actually really close to what was observed. So that may, I don't know how this will go. Then with the extra larges, we sold 53, but what was expected was 20% here of the 220. Okay, 20% are extra large of 220. So n times p there is 220 times 20%, 0.20. Okay, so that should have only been 44 extra larges sold, but we sold 53, so that's a little off. Okay, and then now we're going to start constructing the chi-square statistic. So the chi-square statistic, you have to do O minus C squared over E for each of these categories, and it wants 4 places after the decimal here. So I guess I'll go ahead and start computing that. So on the first one, the O is 12, so put it in parentheses, minus, 12 minus 22. Okay, close parentheses and square, and then you divide by E, which again was 22. Again, I always put a decimal here unless you want it to come out as a fraction. So I'll just put that point, and here it'll come out in decimal. And again, it wants 4 places, so we'll have to put in 4.5454. 55 actually. So ain't gonna work. 4.5455, yeah. Okay, next one, I'll clear that. And same thing here. And the next one, the O is 69, the E is 66. So this is gonna be pretty small. 69 minus 66. Okay, we'll square that. And divide by E, which again was the 66 there, the expected frequency. Put a point in there. And so you get 0.1364. Okay. All right, next one, this will come out even smaller because it's so close. We saw 86, we expected 88. That's really close. Anyway, I'll clear that and start with a fraction, parenthesis, O minus E, that's 86, minus 88, squared over E, which is again 88, and with a decimal point there. So 0.0455 this time. 0.0455 with 4 places after the decimal. Okay, one more with the 53 and the 44. So 53 minus 44, it's a little bigger. So it just kind of indicates that the fit isn't as good there. The hypothesis is kind of off. Anyway, and then divide by E, which is the 44. Okay, like that. And so we got 1.8409. Like that. And then I'm going to check all these before I start doing other computations. Yeah, so these are all great. And so we just need to add those up. And so I guess I'll do that over here. So first one, 4.5455 plus 0.1364 plus 0.0455 plus 1.8409. Like that. So I add them all up. 6.5683. Got my fingers crossed here. Like that. 6.5683. Good. All right. And then let's just check that. Looks good. All right, so now we want the critical value. So I guess I'll go ahead and draw a little picture now. So chi-square distributions usually look like this, kind of a right-tailed distribution. Okay, and you would have a critical value over here somewhere where the area of the tail here is alpha. These are always right-tailed tests. Our alpha is 0.01. Okay, so right here, our chi-square critical value. Okay, and so we have to look that up on the table again. It's a 0.01. The degrees of freedom, let's look that up. So degrees of freedom is categories minus 1. So K is categories. Okay, so the categories are just the different t-shirt sizes: small, medium, large, extra large. So that's 4 categories, but we do 4 minus 1. So 4 minus 1, of course, is 3 categories. So it'll be 3 degrees of freedom with a 0.01 alpha. So let me just slide up to that table. Okay, so with 3 degrees, hang on, 3 degrees of freedom. Remember, again, it's right tail test always, so your alpha is 0.01 on the right tail. And so it's way down there, and here is our critical value. 11.3449. Okay, and again 3 degrees of freedom. So let me slide back here. And I'll just denote this 11.3449. Put it in here. We'll check our answer. Hopefully it's gonna be okay. Looks good right here. Okay, now a p-value comes next. There are no tables for chi-square p-values. You have to use a computer. So I put in a little graphic here that will kind of give you the area to the right of your test statistic. And again, our test statistic is 6.5683, but we're gonna have to round this to the nearest tenth just because of the technology. So if you round the test statistic to 6.6 here, we can just dial that up to 6.6. It'll be close enough right there. Okay, and you can see the p-value here is the area to the right, so it's a 0.086. Okay, and we'll check that. Okay, I've got these clicked here. I don't know if those are right. So with a 0.086 p-value, I'll go ahead and just do a couple notations here. First of all, our test statistic was 6.5683. It's way over here on the graphic. So that's our chi-square test statistic. 6.6583. Okay, and it's not significant because it's not in the tail. Okay, so we'll just kind of assume that we won't be rejecting the null hypothesis because we don't have significant evidence to do that. Okay, so and the p-value came out to be basically where did it go? Down here, 0.086. Okay. I'm just going to focus on the 0.08. Okay, and 0.08 is actually substantially bigger. That's 8% bigger than 1%, 0.01, which is our alpha. And whenever it's larger, we fail to reject on the null hypothesis. And that means we don't support the alternative. Okay, so let's go ahead and punch this out. Make sure I've got these in. This says fail to reject. I don't know why these were already selected, but this one's a fail to reject here. And so that's fine. And then I got to think about this conclusion here. I don't know which one of these is right either. So it says the data do not warrant rejection of the given t-shirt size proportions. Yeah, we are not, that's the null hypothesis. The given proportions was our null hypothesis, and we are not able to reject that. We are failing to reject it using these words up above here. So I'm going to go ahead and say the data don't warrant rejection of the null hypothesis. That looks good to me, and we should have gotten 5 out of 5, which we did here. So everything is A-okay.